Hey, well, you made it through your first 6 weeks. I'm very proud of y'all. So here we go. So we're going to start using derivatives now to explain real life phenomena or stuff that's more in what you can see as tangible and touchable. So it's not just some algebraic trick. All right. And so we're going to get right into it, and we'll talk a lot about a lot of great things, including velocity and position and acceleration and other just rates of change. How can calculus help us in the long run? Or how can calculus help us with everyday things? So first one here says, find a rate of change of the area of a circle with respect to its radius. So in this one, you have to remember, hey, I have a area formula for a circle. And what is it asking me to do? It says find the rate of change of an area with respect to its radius. So what is it asking for? It's asking for, I want to find dA with respect to r. Take the derivative of a with respect to r. So when I go ahead and do that, and I take dA dr, okay, pi, you gotta remember pi is a number. It is not a variable. All right, so this is not a product rule. And I'm going to take 2 times pi, which would be 2 pi, times r, reduced by 1, just r, 2 pi r. Well, that in itself is interesting. Okay. So what does that mean? So it says here evaluate the rate of change of a at r equals 5 and r equals 10. So when I do this for part B, it's asking me to find a prime of 5 and a prime of 10. That's simply just plugging in and finding out this is going to be 10 pi and this is going to be 20 pi. Okay, all you're doing is plugging in for dA dr, because remember the derivative of a with respect to r is the same thing as saying a prime. Finally, it's asking for if r is measured in inches and a is measured in square inches, what units would be appropriate for dA dr? So again, what I'm looking for, so when I go ahead and work for C, again, dA dr, they tell me that a is measured in inches squared. Okay, so it's measured in inches squared per inch. Now you're going to tell me, well, the inches squared and the inches can cancel out, but you have to realize, what do they represent? Okay, so inches squared represents area. So you would say inches squared represents area of my circle. But what does the inches represent? The inches represent each inch of my radius. So inches, okay, of radius. And inches squared divided by inches of radius, you really can't do that. So it actually, what it's measured in is inches squared per inch of radius, or inches squared per inch. Okay, you can't just simply cancel out as much as you want to. All right, you have to be careful with your labels. All right, that's what this little example is supposed to teach you. Now we have a whole lot of vocabulary that we have to go through. Okay, that talks about velocity and rates of change and all that other good stuff that talks about a particle. So in calculus, we get into a little bit of physics. Our little bit of physics revolves around a motion along a line, or specifically particle motion. Okay, particle motion along a line. Okay, either it's going to move up and down or left and right. That is it. We do not get into 3 dimensions. We do not worry about gravity vectors or force vectors or anything like that. We just worry about motion along a line. And so then we have some common vocabulary. You're going to have displacement, okay, which is your change in s. Change of position is your change in s. Okay, so s represents position over a time interval, t, the t plus delta t. Okay, so what does that mean? That means that if I ask you to find what is the displacement over the interval, over the interval of 1, 3. Well, you would just go ahead and set up of, well, my displacement is equal to s of 3 minus s of 1. Okay. Okay. Average velocity, okay, is the change in position over the change of time. Hey, that looks awfully familiar. Average velocity, okay, can relate to what you already know as average rate of change. Why? Because velocity is a rate of change for position, okay, whereas the change in s is over the change in time, which is just like your change in y is over the change in time, which is really going to be equal to, okay, s of b minus s of a all over b minus a, where b and a are times. Okay. To find an instantaneous velocity at time, take the limit as t approaches 0 of this average velocity. In other words, okay, the instantaneous velocity, okay, is equal to s prime of t, which is equal to v of t. Okay. Instantaneous velocity is the derivative of position with respect to time, which is what I just showed you here, ds dt, okay, which you can also remember, this can also be written as s prime of t. So just to recap, when I have position, a position function, I usually call it s. Okay, that s tells me about the change in just position. If I find out the change in position, that change in position is called displacement. When I take the derivative of that displacement, okay, derivative of that position, I find out that my velocity. All right, let's do a couple more. Okay, so just to take a look at this. All right, this right here, the blue line, that is my position function, s of t. Okay, when I want to find out what my average rate of change or average velocity from 2 to 5, that's my secant slope, which is what I just talked about, right? Okay, that is my secant slope. My tangent slope is a speedometer reading. So if I ever want to sit down and I'm looking down, I want to see what my speedometer reading is right now when you're driving, that's your instantaneous velocity, or just your v of t. So this value of my slope is the same as whatever velocity of 2 is, because that's where 2 is at. All right, because that's where it's 2. Okay. So just get an idea of what this idea looks like graphically. Next, when I sit down and look at some other vocabulary words, okay, you may think that speed and velocity are the exact same thing. Speed and velocity is a little bit different. Speed, okay, speed does not care about direction. Velocity does. When you talk about a velocity, velocity cares about direction. Direction. Okay. A positive velocity means moving right or up. A negative velocity means you're moving left or down. Speed doesn't care, so that's why speed is the absolute value of velocity. Speed is always positive. All right. Acceleration is the rate of change of velocity. Rate of change of velocity. That means it is the derivative, okay, of velocity, which, if you're keeping track at home, is the second derivative of position. So I can rewrite this statement as saying, well, acceleration is the same thing as saying v prime of t, which is the same thing as saying s double prime of t. So when I take the second derivative of my position, I will get acceleration. Or when I take the derivative of velocity, I get acceleration. Okay. Whew. All right, that's what you have to know. Those are the things that you have to have memorized. All the stuff I've talked about at this point, you have to have memorized. Okay. This right here, this part right here, is a nice to know. This is kind of like, you know, a distance that bodies falls is proportional to the square of the time it falls. Okay? And so if I just take any object and drop it, this is what defines its position. And depending on which unit I'm in, if I'm in, you know, feet or if I'm in meters, it depends on what G is. Okay? Now if I have a projectile motion, this goes along the same type of thing right here. Again, nice to know, but not necessary. Okay, this is a part of the physics where you don't need to know this stuff for the test. What you do need to know is everything above this, the acceleration, the speed, all the stuff I talked about earlier. Okay, so let's take a look. What I'm going to do is I'm going to give you a brief, I'm going to pause it right here, and I'm going to just let you guys decompress for a little bit, and this will be the end of the first video. Okay, so the end of the first video, and this is what you can watch tonight, kind of decompress, put it all together. Okay?